Welcome to this demo of Zero Trust Connectivity, which is a reference architecture and an implementation of how various technologies can be stitched together to provide us end-to-end secure connectivity for applications from the vehicle to the services that are delivered via the cloud platforms. Let's see how that happens. So imagine in the near future, a customer intends to buy a car. The car will have all the hardware and electronics inside this, and the software and applications need to be configured on top of it. So the first step is really enrollment of that customer's private key with the vehicle, and that is like giving an identity to the vehicle. The next step would be to get the software that is to run in the vehicle delivered via the various cloud services into the vehicle in a secure manner. This software would be bundled as containers and delivered as container images into the vehicle that would be executed in the container cluster runtime within the vehicle. The next step is really to connect a pipe from the vehicle into the communications domain. So for that, we would have a secure connectivity platform that the vehicle would be communicating with. And the identity that was associated to the vehicle would be used to make an interaction with this secure connectivity platform. The fourth step really would be to give an entitlement of which cloud services this vehicle can communicate to and talk to. And that's the configuration that would be done by the dealer or the OEM and can happen in a dynamic manner. So new services can be onboarded into the vehicle based on the entitlement that is given to the customer's vehicle. Let's see that how this happens from an architecture perspective. So consider a vehicle with a TCU board and a HSM module integrated or augmented into it. There are a few services that are delivered and downloaded into the vehicles as container images. These applications can be based on AWS Greengrass, or they can be cloud native container images delivered onto the vehicle. And that would run in the container cluster environment of the vehicle. In order for the application to interact with the crypto functions on the vehicle in a standardized manner, we would be using the parsec service, which would provide abstraction to the way applications will interface with the crypto functions provided on the vehicle TCU board. Consider that there are a few application services that are provided by different vendors over AWS cloud using varied technologies. So in this example, consider that there are location services which provides real-time tracking and trace information, and telematics service which provides analytics about the health of your vehicle. The goal is to make a connection between the application and the services in a secure manner. To do that, we would be using the NetFoundry platform, which allows us to provide a secure tunnel between the applications and the end services. Next, we would use the NetFoundry console to provide association between the application on the vehicle and the services that are on the cloud. You can have additional services which can be based on these services, and we provide value add information and services like analytics and real-time location information on top of the services that are delivered via AWS cloud. Let's see that in action. So first we would associate the HSM with the vehicle. Second, we would install this TCU into the vehicle. We are now going to create a private key and a public key inside the HSM module that we have installed in the vehicle. If you see, there is a key that is created in the HSM. Now we are going to take this particular key and create an identity JWT token based on this particular key, and use this token as a identity provider or authentication provider into the city client. As you can see, the tunnel that is created between the board and the city is using the key that was generated right now. And here is where you see the two applications that are installed and enlisted for sending data from this board to the cloud services. Now we go and create and start the Greengrass services on the board. The Greengrass service runs as a daemon. Next, we are going to create a proxy service which to the AWS IoT, such that the messages that are sent on this proxy is sent to the AWS IoT. As you can see, a proxy service corresponding to the AWS service has been deployed within the vehicle. Now we'll look at the services that are exposed from the Amazon Web Services side. To start with, we'll test what kind of data is coming to AWS IoT. We listen to the particular topic, and then we see a bunch of data is coming on this particular topic. In order for us to do analytics on the data that is coming on AWS IoT, we will create a channel, and on that channel, we would see the traffic flow of messages and data that is pumped from various vehicles into the AWS IoT. Next, we want to do some analytics on top of it, and visualize the data in a particular structure. So for that, we are going to create a data pipeline and pump that data into a data set. The analysis data can be plotted on various visualization tools like map. In this case, you see the latitude and longitude placed on the map. Now let's look at how the mapping of the services and the endpoints is done. So this is the NetFoundry console, which allows us to map the various services that are exposed from the cloud vendors. In this case, we have telemetry services and the geolocation services that we want to map against certain endpoints. This is the place where in the WAN configuration, you would be doing a mapping of which services are available to which endpoint. So as you can see, there are 3 services and the endpoints that are allowed to send messages on this particular service. The console on the NetFoundry shows the real-time traffic utilization and network utilization along with the active endpoints and the services that are consumed. And finally, we show the UI of the vehicle moving on a map based on the services and the data which is pumped from the vehicle into the services. As a recap, this implementation and this architecture allows OEMs to onboard new services onto the vehicle in a dynamic manner and allow dynamic provisioning of these services and association of that with a category of vehicles, such that the innovations and capabilities of the vehicle can be increased over time using software. The software that is delivered into the vehicle always connects via a secure platform, such that the data that flows between the vehicle to the services is encrypted end to end. And second, there is no inbound connection into the vehicle, such that the attacks or threats which can happen on the vehicle otherwise do not happen. Thank you so much for watching.